Hello everyone. So in this video, let us talk about a easy level problem from LeetCode. The problem name is find if path exists in a graph. So the problem statement goes like this, that there is a bidirectional graph with n vertices where each vertex is labeled from 0 till n minus 1. So we'll also take some example. So as you can see here, let's take this as an example. You have a graph and it's a bidirectional, which means that you can move in both directions. It has labels from 0 till n minus 1. Now you can see what is bidirectional graph is. What you're given in the problem is edges from different nodes, as you can see here, whatever edges you are available with. And you have to determine that whether there is a valid path that exists from vertex source to vertex destination. So you're given, let's say, a source, let's say 0, and destination 2. You just have to understand that and like tell that whether there is a valid path that exists from a particular source node to a destination node. That's it. Now, what you can see here is that you don't just actually have to optimize on the route. Okay, if you have to find out the shortest route, then the algorithm that we use for shortest route is called BFS, breadth first search, that will tell us the shortest route. But a more easy version of finding out a path between two nodes is DFS, which used recursion, which is depth first search. So you can use DFS here as well. Now, what DFS does is that in recursive form, you'll start from a particular node. Let's take some example. Let's just start from this particular node. Now, from this node, you'll iterate over every possible node that is possible. Let's say this is one node, this is one node, and so on. And what you'll do is that you will first go to any one of them node. Let's say I'll first go to this node and then iterate over all the possible nodes it is connected to. So it is not connected to anything. So we can go to here as well. Okay. Then we'll follow towards what all nodes this node is connected to. So we'll first iterate over all the nodes this is followed to. This is connected to this node as well as this node. So we'll take this node first, iterate over all the nodes connected to this node first. Okay, now come to this node. Okay, so we will first iterate over this and now iterate over all the nodes connected to this node. So this is connected to this and this. So one by one, you can take one by one, iterate over all the nodes that is connected to a given node. And in the end, you have to store what all nodes you have iterated over in this particular process. So as you can see that I started from here. So you have to also keep track of that what all nodes that you have already traversed. So you have traversed over this node, you have traversed over this node. So that in the end, if you traversed over this node, let's say if this node is like you can say marked, which means that you have a particular valid path such that because you started from this node and you only traverse to only those nodes that is connected by this particular node. So if you have reached somehow this node, which is like say a source and destination, you already know that there is a valid path that exists here. Okay, that's the overall solution that you have to use. You can also read about DFS on various platforms. You can find out different videos of mine as well. You can read different articles on DFS. I'm using a simple DFS technique to find out where there exists a path that from source to destination. That might not be the most optimized or shortest path. For shortest path, you will use BFS. Okay, you can use any one of these algorithms to find out the shortest path. So now let us understand the code part now. So what we have done is that this is the main function that is called valid path, that whether there's a valid path or not, it will return a Boolean variable that true or false. Okay, whether there's a path that exists or not. Okay, now it has the edges vector. Now what is this? It store all the edges between any particular nodes that exist. Okay, so what we'll do is that from this edges array, we have to form an adjacency list. Okay, now what is adjacency list? Adjacency list stores that for every particular node, how many nodes are adjacent to it. Adjacent means like just you can say connected to it. So for adjacency list of 1, we have 0 and 2. For adjacency list of 2, we have 1 and 0. Okay, so you have to form that. So we will use this edge array because this stores that there is a connection from 0 till 1. So there's a bidirectional, which means that there's also connection from 1 to 0. So we will iterate over every edge possible. and make an adjacency list. So this is a 2 into 10 to the power 5 because of the constraints. If you see the constraints here, the constraints is at 2 into 10 to the power 5. That's why I made an adjacency list vector, an array of vector of 2 into 10 to the power 5. And this is the visited array that will show that whether I've iterated over a particular node or not again. We'll talk about in the code part now. So what we have done is that we have formed the adjacency list. This is a very standard practice how you can iterate over maps. So for not maps, sorry, for graphs, you have to make an adjacency list. So that is very simple to make that. Now you have to start a DFS function, and then in the end, we'll return that whether in the visited array, that will show that whether if I have started my DFS from a particular source, is there is a valid path to the destination, which is marked by visited array, because visited array will store out all the nodes I have traversed in the form of DFS when I started from the source. Okay. Now what we have done is from the DFS, if I am at any particular node, that is you, I will first mark it in the visited array. And then what we have done is that iterate over all the particular nodes this adjacent to, which is like it is connected to. So we'll iterate over all of them one by one, and then call the DFS function again if you have already not visited it. If I have two nodes, let's say three nodes, I started from here. If I've connected and iterated over this node already, okay, then I go to this node because I have to iterate over all the nodes connected to this node. I will first mark this. Then go to this. When I go to this, this is already connected to this as well. So which means that it might form a cycle. I can go in endless cycle. So we have to keep track that I should not reiterate over nodes which is already iterated. So it is already marked that I have already visited over this. Don't go over that particular cycle again. So for that, this visited array is there, which will tell us that if it is already iterated, this not symbol tell that we will only go inside this if loop, if condition, if it is not iterated. If it's not visited, then only call our DFS function again for our, you can say, recursion, such that we have to now recursively iterate over every possible node and do our DFS again. So it's a very standard DFS code. You can read about DFS again and again or through different articles, and it will become more intuitive to you. It's a very small and simple problem, and this is a very easy version as well. So thank you for watching this video till the end. If you still have any doubts, you can mention in the comment box of this particular video. I will see you in the next one. Keep coding and bye.